Hello all, this is part one of a series on respirators and the coronavirus. It's prepared to educate you on respirators and how they protect us from inhaling the coronavirus. I am a certified industrial hygienist and a scientist who has performed research on respirators. I do not have any affiliation with a respirator company. The purpose of this series is ultimately to help you make informed decisions if deciding to purchase a mask or sew your own mask. This first session will focus on what's in the air that we don't want to breathe in. And as a caveat, I will be showing images I have obtained from various websites. I will show the URL they were obtained from, if known. I have developed this series as a public service during this coronavirus outbreak, and given its purely educational content, I am hoping that any potential copyright infringement is disregarded. Likewise, some images are directly from company websites, but I do not intend to endorse any particular company or brand with this series of videos. So with that, and an apology for the low-tech way of getting this information across, let's get started. So this is a coronavirus, and as you can see, it has a spherical shape. When it is in the air, it becomes one of many small particles we breathe in with every breath. The main point here is that we are now focused on preventing acquiring the COVID-19 illness by minimizing our inhalation of the virus floating around in the air, as versus how we can acquire it from a surface we have touched. So the coronavirus can be transmitted from an infected person to a nearby person when the infected person coughs or sneezes. Even pronouncing hard consonants can eject small droplets from our mouth. As shown in this diagram, the virus will initially be floating within a droplet, but with time and distance, the droplet may dry to the point that only the virus itself remains, either singly or clumped together. So how big is a virus? First, it's necessary to establish a reference for their size. This graphic shows a human hair relative to very fine beach sand. The diameter of hair is about 50 to 70 micrometers, where a micrometer is 1/millionth of a meter, or about 1/millionth of a yard, very small. A dot on white paper that is 50 micrometers in diameter is about the smallest speck that we can see. Wrapped like a ring around the single hair shown are little blue spheres that are 10 micrometers in diameter, for reference to the size of a single virus that we'll see in the next slide. So now on the right, you see that 10 micrometer particle as a rather large rock compared to the little blue virus particle looking rather small because it's only 1/10 of a micrometer in size. And what about the droplets that we cough out? Because they could be inhaled as well. Here are the results from two studies with measurements of those droplets. The results don't agree entirely because they use different instruments, but in general, cough droplets can be closer to that 10 micrometer particle and have a wide range of sizes, but the majority are less than 2 micrometers in diameter. Note that the droplet nuclei mentioned here is the dried remains of the original droplet expelled when coughing that has then evaporated. So now that we know what we are trying to protect ourselves from, part 2 will cover the different respirator types used to capture particles, including viruses and droplets as the special kind of particles we are interested in now. Thank you.